welcome to Cochem Academy. Today I will discuss another important name reaction of carbon compounds, that is the Cannizzaro reaction. And in last video, one of the last video I have discussed about Aldehyde Ketone reaction. So this is also important name reaction, that is Cannizzaro reaction, and it will come your ISC or ICSC or your CBSC or any competitive exam, JEE, NEET also. Okay, so these are important, not ICSC, it is ISC. So Cannizzaro reaction. Now this is quite related with the Aldehyde Ketone reaction. We've seen that that Aldehyde Ketone reaction are done by the compounds which have the alpha hydrogens, but the Cannizzaro reaction will be done by the compounds which don't have alpha hydrogens. So the compounds which don't have alpha hydrogen, they will participate in Cannizzaro reaction in presence of concentrate alkali, that means concentrate sodium hydroxide. Okay, so first of all we have to see which one is alpha hydrogen. Now this one is carbonyl group. This carbon is delta plus and this oxygen is delta minus, because this carbon is less electronegative than the oxygen. So this carbon will pull the bonded pair of electron towards itself more. So this carbon will get delta plus, this oxygen will get delta minus. Now the carbon which is directly joined with this, that is neighbor to the carbonyl carbon, is called alpha carbon. And if this carbon is sp3 hybridized, if this carbon is sp3 hybridized, then the hydrogens present here are alpha hydrogens. These hydrogens are alpha hydrogens. Okay, so the neighbor carbon of the carbonyl carbon is called alpha carbon, and the hydrogens attached with it, it's called alpha hydrogens. Now the compounds which have alpha hydrogen, they will participate in Aldehyde Ketone reaction, but the compounds which don't have alpha hydrogen, they will participate in Cannizzaro reaction. Okay, so the compounds which don't have, the compounds, carbonyl compounds, the carbonyl compounds which don't have alpha hydrogens, okay, participates in Cannizzaro reaction with strong alkali, that is sodium hydroxide, concentrated sodium hydroxide. Okay, so let us consider one example. Okay, so we know that now you tell me that this formaldehyde having alpha hydrogen or not. This formaldehyde, this is the formaldehyde, so this will not have any alpha hydrogen, because this carbon is the carbonyl carbon and it is not attached to any carbon. So this carbonyl carbon having no alpha hydrogen. So what is the process here? 2 mole of compounds having, carbonyl compounds having no alpha hydrogen will react with concentrate sodium hydroxide to form one alcohol and one carboxylic salt. Okay, carboxylic salt of an acid. So that is the reaction. Okay, so it will form an alcohol with the acid, that means salt of an acid. Now if 2 mole of formaldehyde, this is 2 mole of formaldehyde, reacts with concentrate sodium hydroxide, it will form methanol plus sodium formate. As it is formaldehyde, so it is forming sodium formate, that means salt of formic acid, and it is forming an alcohol, it is methanol. Okay, so one aldehyde or ketone, aldehyde will be converted to alcohol and another one will be converted to acid salt. Okay, so this is the actual reaction Now we will consider the mechanism of this reaction. Okay. Now mechanism of the previous reaction, that means formaldehyde with sodium hydroxide. Now this formaldehyde, first of all, one formaldehyde, okay, will react with the base, that means sodium hydroxide. Now sodium hydroxide will dissociate to form Na plus and OH minus. Now this OH minus will readily attack this positive center because the carbon is delta positive and it is negative. Okay, and it is a nucleophile. So here it will attack, and as soon as it is attacking with joining with this carbon, the valency of this carbon increases. But we know that valency of carbon is should not be more than 4. So here it is attached CHCOH, and so that this carbon will release this oxygen, so this bond will be released, so O minus. Okay, now that means it's form a anion. Okay, now this process, the first process is the very fast process. Okay, this process, this step is very fast step. Okay, that's why it is not the rate determining step of the reaction, and here only one molecule participated. Okay, now in the second step of the reaction, we have to take another formaldehyde molecule. Now what will happen, that here from this molecule one proton will be migrated to here and will form an alcohol and acid. That means if this oxygen is forming a double bond here, this oxygen, this O minus, that means minus charge will shift towards the neighbor bond. Okay, so that the valency of this carbon will increase. This is the mechanism of the reaction, and this process is very slow process. This process is very slow, and it is the RDS, that means rate determining step of the reaction. So this negative charge will shift towards the neighbor bond, so the valency of this carbon will increase, so this hydrogen will migrate, and that means it is the protonation. This and this carbon is delta positive, this is delta minus, so it will attack here. Okay, and again this will be released. So what will form? First of all, you have to see this one, HC, this is O minus H. Now as this hydrogen is shifted towards this C, so we can write like this, simple. Again here HC, this is making a double bond to, and here it is OH, so it formed an anion, that is CH3O minus, and it is formed a formic acid. Now this cannot be a stable compound, so what will happen, here will be our internal proton donation, that means this formic acid will donate one proton to this methanol. Okay, internal proton transfer will be there, internal proton transfer, that means if this formic acid is sent one proton from here to here, then it will form CH3OH. It will form CH3OH plus, and it will form, and after that, after sending this hydrogen to this CH3O minus, it is O minus, so after that it will take up this Na to form HC double bond ONA. Okay, so I think you have understood. Now if you like this video, then do like, comment and subscribe my channel, and try to see the full video. Okay, so this is the total mechanism of this reaction. So what I have got, we have got sodium formate with methanol. Now we will see another example. Okay, we will see another example. So I am using this one. Now we have seen that formaldehyde can take part in Cannizzaro reaction. Now benzaldehyde also can take part in the Cannizzaro reaction. This is aromatic aldehyde, benzaldehyde. So benzaldehyde is this is nothing but this one. Now this benzaldehyde don't have any alpha hydrogen. Why? If you expand the structure like this is benzene. It has a double bond. Now I have told you that this carbon will be alpha carbon, but here this carbon is sp2 hybridized, and there is no alpha hydrogen here, no alpha hydrogen. Okay, there is no alpha hydrogen in this compound, so this compound can take part in the Cannizzaro reaction. Benzaldehyde can take part in the Cannizzaro reaction. Okay, 2 moles of benzaldehyde will react with sodium hydroxide to form benzyl alcohol and sodium benzoate. Okay, so here this same mechanism. Okay, first of all, in the first step, NaOH, OH minus will attack here this carbon, delta plus, delta minus, first process. Okay, this is very first. So it will form PHCO minus AH and OH, same as the before. Okay, so it is the first step. Now in second step, we have to take another molecule. PHC double bond to H. Now this O minus will shift to, that means this negative charge will shift to the neighbor carbon, so that the valency of this carbon will increase. So after that, this hydrogen will shift here, because this is delta plus, delta minus. Okay, now we will see this compound PHC. It will be O minus. Here one H and here one H. This H is shifted here, so I am joining here. Okay, and from here, so from the second molecule, this one you have to keep in mind that from the second molecule we are getting the alcohol, and from the first molecule we are getting the carboxylate salt. Okay, so and next one here we will get PHC double bond O HOH. We can write like this also, here H and here H. Sorry, AH. So this is benzoic acid, but there will be an internal proton transfer. One hydrogen will be shifted from here to here, so it will form PHCH2OH, benzyl alcohol, with that here PHC double bond O minus will be there, and after that O minus will take up one sodium. That means NaOH is here. NH is forming Na plus and OH minus. So here it will take up to form sodium benzoate. So this is the process. Okay, so we have seen one aromatic aldehyde can take part in the Cannizzaro reaction. One of the example. So many compounds are there which don't have any alpha hydrogen. They can take part in the reaction. Okay. Okay, so what I am telling, that so many compounds are there which can take part in the Cannizzaro reaction. Okay, so now we'll discuss another type of Cannizzaro reaction, that is called intramolecular Cannizzaro reaction, and it is also very important, intramolecular Cannizzaro reaction. Okay, intramolecular Cannizzaro reaction. Intramolecular Cannizzaro reaction. Now in a particular molecule there will be alcohol and a salt of an acid. That means, say we are taking this compound. Okay, now when this reacts with a 50% sodium hydroxide, that means concentrated sodium hydroxide, after that hydrolysis, then what will be the product? Okay, very important reaction this one. So first of all, you see, in a particular in this compound, this NaOH will dissociate to form Na plus and OH minus. Now this compound we know, that is C double bond O. We can write like this, and here also we can write like this, C double bond OH. Okay. Now if OH minus attacks this carbon, then it will form an anion. So here HCOH, O minus, C double bond OH. Now same process, after attacking of OH minus, here there will be a proton H minus shifting will be there, but here within the same molecule. That's why it is intra, within the same molecule. Okay, so what will happen? This negative charge will shift towards the CO bond to make C double bond O, and so that this hydrogen will shift here. Okay, and this kind of rearrangement will be there. It is H minus shift. Okay, so it will form CH double bond O, CO minus H. Okay, now up here we have seen what is forming here. Actually, sorry, it will be OH. Okay, so after that here transfer of, that means the internal transfer of H plus will be there. That means same as we have seen before, that this will make OH and it will be O minus. So it will form C double bond O minus, and here CH OH hydrogen. Okay, it is clear. So what it is forming actually, it is forming, this will be COONA, this will be COONA, or you can make COOH also. Okay, so what we have got, that OHCH2 COOH. Okay, OHCH2 COOH. Okay, so it will form, after if you do the H0 plus here, that means hydrolysis, it will form C double bond OH. It will take a proton from here, and it will be also COH HH. So what is the compound we are getting here? We are getting here actually we can write like this, OHCH2 COOH. So this is the compound we are getting here. Okay, so there are so many intermolecular Cannizzaro reactions are there. So if you want to know more reaction, you just comment me over comment box that I need to know this reaction, so that I can make another video on intermolecular Cannizzaro reaction. Okay, so now if you like this video, then do like, comment and subscribe my channel, so that I can make more videos, and on class 11, class 12, and also for other chemistry topics. Okay, so thank you.